there any questions? Any problems you'd like me to do in class? Yeah. I can't tell you. When I get into Alex, I'll be able to tell you. There's probably homework due every day. Let's see. No, I'm pretty sure there is. Let me get these in here. Why not? This is math 0955. Let's see what we have yet. Assignments. All right, we got up to 3-2. Good. Okay, so today we're going to do, 3-2 is going to be right here, 216. So yeah, 3-1. I gave extra time on 1-7 because I forgot to assign it. But are there any questions on any of that stuff? Yeah, if you have, just make a note of it and bring it in class. I can do them. I can copy and paste any of these problems into what I'm doing on the screen. All right, let me put this so that they can see at least something that's going on in this class. All right, then today is 3.3, which is called applications. Do you know what that word is indicative of? Anybody? Applications. What does that mean to you, do you think? It means word problems. Everybody's favorite. So what I'll do then is, what is? So I'll create a homework here so you can see the way it works, generally speaking. Okay, so this is homework. We're going to do today 3.3. So I'll put homework 3.3, like so. The due date will always be a week from the day. That way you can ask questions about it on Wednesday before it's due. Now, by the way, when it's due, that's not the end date. That's the last date for you to get full credit. You can still get 90% credit for any problems that you haven't done later on. You can go back and it's a good study tool. All right, let's see. What am I grabbing here? Chapter 3, 3.3. All word problems. That's all we're going to do today. I'll say one more time before I begin 3.3. Are there any questions? Okay. I remember last time saying the homework was hard enough to warrant some questions, but I guess not. Add one more of these.
Explain how the problem is broken down.
Uh-huh.
It went like, distributed.
Uh-huh. All right, hold that thought for a second. Do you see what I'm clicking on here? Allow late submission. I allow you to submit it late all the way up until the last day of class. And you get a 10% penalty if you're late. Okay? That's all there is. Now there's a 3.3 in there. Okay, well, what section was it? Do you know the problem or anything like that? I think today it was due 1.7 and 3.1. Midnight. All right, that's the one I think. Okay, well, we might as well do it while it's on the screen. Can you guys, I can make this bigger if you want. Can you guys see it? All right, so we have this equation is solved in several steps below. So, part one is the given equation. All right. Can you tell me then, all I want you to do is to look at this equation and what did they do here? Tell me what they did. It's not the same as this, is it? It's, so what do they call that multiplication? Because they multiply it to the W and the 2. What do they call that multiplication?
Distribution.
Exactly right. Now, what did they do here? We usually put a little minus 16 underneath, but they don't do that. What did they do? What? They subtracted 16 from both sides, right? They call that the subtraction property of equality. Means you can subtract the same thing from both sides and it still be equal. What happened here? Can you tell me? From this step here that I'm hovering on to this step here. Simplified, right? What did they do here? They divided by what? What property is that? If you looked at these properties, what would you guess? There you go. And last, we must have done a little simplifying to finish it off, huh? Let's check it. So they're just trying to get you to understand, to label each and every step. Most students, I think it's not that bad. I think it's a pretty good problem because most students will not be that meticulous when they look at problems and solve them. And so a lot of times you'll do all these things, but you won't be able to probably tell me every step that you did. And that's what this problem is trying to get you to do. It was only one of them though, right? Okay. No, because I can't do these drop downs on a test. Although you could probably do matching, but if you look at my old tests, I've never put a problem like this before and I don't intend to. It's there to get you to learn the process. All right, are you guys excited about word problems then?
Yes. Can't be waiting.
I'm excited myself. So I'm glad to see that. What do I want? We're gonna grab problems out of the textbook, I think. Making these up the top of your head is not a smart idea. What they do is they break it down into different styles of problem. Let's see here if I can get into, not that. Chapter 3. That's not it, 3.2, 3.3. And give me the end. First, you always, any of you guys use this textbook? Anybody read through it? They have all sorts of things like that. Did you see this stuff? Like if you go through it, I think if you read besides hints and stuff like that, they have a lot of examples, but there's also, let me see if I can find it in here. You have a better textbook than what anybody could possibly have. Let's see what comes up here. Yeah, that's not what I was talking about, but that's okay. Not exactly sure where it took me though. Oh, that was a different thing. Okay. What I'm looking for in these, they have videos. You have to look through them, but I'm not sure. Solve problems. That's that. I don't know what this does though for me, if it's a video or, oh yeah, it is. Okay, see this? Although I hear nothing. Oh, that's because I did this. So these are all over the textbook. So they're all over your textbook. That's why they have a lot more like a normal textbook. If you had a physical textbook, you obviously wouldn't be able to do that. Well, we'll start from the earliest problems and then we'll work from that. So we'll start at the simplest possible one, and I'll take number 2. You can do as many odd ones as you want out of the textbook. The answers are literally right under that button. All right, so let's do a new one. View. Those things. All right, first also I must fill you in on something. You see where it says write an expression? It didn't say write an equation, did it? What does an equation have? Equal sign. If it's not an equation, then it doesn't have an equal sign. So right here, this says an expression. It doesn't say an equation. So I am not expected to have any kind of an equal sign in this answer. All right, during a Little League game, Tigers scored. Oh, it's Valentine's Day. Don't forget. I know that I'm not supposed to forget. I'll help you guys out a little. 2/14/2022. All right, we have during a Little League game, the Tigers scored more runs than the Eagles. Write an expression for the number of runs the Tigers scored if the Eagles scored R runs. So let's see here. Why would they use the letter R for Eagles? Whatever, it doesn't matter. So what does this mean?
3 plus.
3 plus. And then what?
R.
That's it. That's the extent of their answer that they're looking for. What this is trying to, the early problems are trying to get used to the terminology. More than meant addition. That is, does that represent 3 more than whatever R was? So it's also part of it is trying to get you to learn how to convert. The hardest part of word problems that I've heard from students over the years is that the hardest part is to come up with an equation to solve the problem. You read these things and they get lost in all the words. And it's hard to figure out what maybe they're even asking you to come up with. So this would never be an answer to a question, but this might be part of the solution. Let's grab something else. So let me let you try one. And number 4. Try that one. What should drop indicate to you what mathematical subtraction? So that means we subtract 15 degrees. So what would this expression look like if it was t before? What is it now? T minus 15. Do you understand? T minus 15. That's all. We're not looking for any answers right now. all we're looking for is a 7 type question. So we have t minus 15. Anybody care to volunteer? 8.5 minus h it is. This is an important problem, so I'm gonna. For some reason, I don't know what this problem or what your textbook was thinking here, but this is absolutely insane. I would never use the letter H for the hours he works in his office. I would use the letter H for how much he worked at home. So if I'm gonna use an office, I'll use an O, but I'll do something to make sure that I don't think it's a 0. So what do we know? And at home, I'm gonna use the letter H for home. So I don't know what this is, you know, they're trying to teach you how to do word problems and then do stuff like this is absolutely insane. The letters you choose should help you, not make it harder for you. Almost. We know that he worked a total of 8 hours. Total of 8.5. That means between working at the office and working at home, he worked a total of 8.5 hours. You understand that? So if I want how much he worked at home, all I have to do is subtract the letter O from both sides. So I get H by itself to equal 8.5 minus O. And that's the thing that they were looking for. They wanted an H there, but I've decided to change the problem to a better one where there's an O instead of that H. And it would make sense that this is the hours he worked in the office, wouldn't it? Eight would be better for that. I mean, at home, I mean.
I'm not even gonna lie, I am lost. Like that whole.
I'm sorry, what did he say again?
You said what?
That's what I'm asking you.
This problem right here just confused me.
Well, I'm trying to, did you see where I scribbled out the H and put an O instead?
Yeah.
All right, make sure you do that because that's important for what I'm doing next.
Uh-huh.
So this equation just says that between the office and at home, this guy is equal to 8.5 hours. Do you understand that?
Yeah.
Okay, now right after that, I just decided to use O and H instead of the whole word.
Right.
All right, and then they wanted the hours he was home. So I solved that equation for H. You see how I subtracted the letter O?
Yeah.
And that's all they wanted.
Oh, okay.
So what we're doing, right now, we're not even solving problems. These are all setup type problems to get you revved up for these word problems. I don't know how to say it, but people have been trying to teach students how to do word problems for years, and it just seems like we never have the greatest success. Nobody seems to have the great success on this. But word problems are the most realistic type of problems you would have. No, I don't. Well, this is an interesting one here. I like this. Look at the problem number 12. Let me make it bigger. It will not let me make it bigger. Once I click on it, I'm gonna make it bigger then. Okay. So I get number 12 up here. There's also, they try to clue you in on things too. Look at problem number 4. I mean, number 12. In there, if they ask you how many people are working in an ice cream shop, does 5 1/4 make sense? No. So sometimes you have to look at your answers and make sure that they make sense. So like, if you have a problem that says, how many bottles of soda pop did you need? And your answer is some negative answer, you did something wrong. Do you understand? So some of these problems are just trying to show you, when the answers are ridiculous. So anyways, we're ready for, well, I don't know if we're ready for them, but we're going to start them. I'm going to grab some word problems. I'll start with Bolin. All right, so Bolin applied to 3 more colleges than his sister Lily. Together they applied to 13 schools. How many colleges did each apply? So what you want to do is, first of all, I would probably use letters that are helpful. So Bolin, I would probably do letter B. And for Lily, I would probably use the letter L. Does that make sense? All right, now we know that they applied to 13 schools. Can you give me an equation for that? Give me an equation for together they applied to 13 schools. Can you give me an equation for that? Say again? I think it's something. I know, so I'm saying, go ahead, say again. That's 3. That's 3. No. Together means that Bolin and his sister, right? So B and L together applied to 13 schools. That would mean that him plus her equals 13. You agree? Yeah. So that's right. So we have Bolin applied to 3 more than his sister Lily. So that means that Bolin equals 3 plus his sister, doesn't it? All right, so here's what I have. I have Bolin was 3 plus Lily, and then I have Bolin plus Lily is equal to. You see that I can take this and replace this here with it? You agree? This letter B right here. Isn't B equal to this quantity? So I'm going to replace that B with 3 plus L. It's B. The rest of the sentence has been left unchanged. You guys follow what I did? See how B became 3 plus L. This plus is right there, this L is right here. I didn't change anything except the letter B. Now, that's an equation that you have now that you should be able to solve. What would be the first step in solving this equation? So, no, what's the first, I always say there's one thing before any subtracting or anything, what is that?
Those common.
Simplify. First thing you should do is simplify each side. So look at the left side of this equation. Is it simplified as it is? What could you rewrite it as?
3 plus 2L.
3 plus 2L. That's equal to 13. This is the one I want to work with. Now, what would you do next? Subtract 3
Both.
sides. So I would get 2L equals 10. Now what?
2 on both sides.
Divide by 2 on both sides. So I end up with then L equals 5. Now, what you want to do whenever you get an answer is go back to the problem and see if you answered the question. How many colleges did Lilling apply to? 5. So that answers whatever, that answers that question, if it was even a question. I don't want the answer. What did they ask for?
Both.
How many got noted each?
Oh, each.
So since each, that means I want both Lilling and him. So let's go ahead and get Lilling. We got Lilling's done. So Lilling was 5 colleges. What about Bowen? Bowen was equal to 3 plus L, right? So if you take that 5 and put it in there for L. So we have Bolin. I don't know if it's capital or not. 8 colleges. And what's her name? Lily. It's 5 colleges. There's 50 problems. We'll try to do all the even ones. All right, so we're just going to start hitting them up. You guys ready? All right, go ahead. Take a few minutes. It shouldn't be much different than the one I just did. If you think you have it, let me know. I'll come around with my answer. And, cause I can't come up close enough to see what you're writing, but I can write down the answers. Find out shortly. Anybody else want to check that? You should have seen those laptops back in those days. I didn't think about it. Most of you probably weren't even born then. They were like, not this big, but gargantuan. Well, what I use is for the MacBook, I'm gonna use the letter M, and for the portable, I'm gonna use the letter P. That's okay. So I use an M for this is a MacBook. P for this, is that okay? Now they weighed a total of 18.1 pounds. Oh, let's get this one first. M weighed about 13.9 pounds less than P. Can you tell me an equation that would relate those two? The subtraction will be in there, but what will it look like? Can you tell me? So we know that it weighs, so it'll be equals. Tell me what goes here and here.
It's 13.9.
Nope. It equals P minus 13.9. It's 13.9 pounds less than the portable one. You guys understand that equation? Good there. Now, also we have, they weighed a total of 18.1 pounds. Give me the equation for that. A total of means what operation? Second equal. You got it. And so with M plus P equal 8.1 and M equals P minus 13.9, do you understand? I'm going to take this thing right here. And I am going to plug it into that spot. The reason why I'm going to do that is because when I rewrite this equation, I'll put the P minus 13.9P. I'll stop there. Keep on what I just did. Reason I did this, the importance, this maybe we overlook the importance of this step. I think I do. But you'll notice in this equation, how many letters do you see in this last equation right over? How many different letters? No, there's only one letter. The letter P. What I'm saying is, I don't solve equations that have a multiple letters. They'll have to have the same letter. And that's exactly what this first equation allows us to do. Now, the first thing we're going to do before anything else is simplify. What is that left side going to simplify to be? All you got to do is add the p's together, right? Then they'll like pounds. We're almost there. What would you do next? Add 13.9. Yeah, whatever you do to one, you have to do the other. So it looks like the right side will be 32. Left side will be 2P. Almost home. Went down and finished off. By 2. You see, everybody's with me when it comes to this part of the problem. It's, well, it's exactly what I was trying to tell you. So how much does our portable computer weigh? 16 pounds.
Oh, that would be terrible on the back. Imagine walking around.
Did you ever see, I keep forgetting your age is you're younger. Have you ever seen movies that show people using cell phones from like the 80s and things like that? They're big. And they had, in fact, some people had a huge console in the middle of their car to hang this thing up. It was a big affair. Computers should make them, shouldn't surprise you. Now, it says, find the weight of each computer. So I haven't answered the question yet. What do I need yet? I've got one. What do I need to answer yet? For the MacBook. So how much was the MacBook?
It was P by 16 minus 3.9.
That's right. That's where you're going to use this equation right here. So we know that M equals P minus 13.9. So I'm going to replace the P with the 16. You'll find out that that's 2.1. That one is 2.1 pounds. Well, obviously, I think the question also, besides having a word problem for you, you can see the difference is startling, isn't it? And plus, the portable ones were big, thick, gargantuan things. Now these things are what? They're paper thin. Well, what they ought to do is probably, maybe they should look at the prices, because back then the price for one of these things was thousands of dollars. Nowadays, they're only thousands of dollars. That's the one thing that hasn't changed much with Apple. I can't afford the Apple portion of the store. They don't pay me enough. I have to go to the AMD part of the store. All right. Let's see if I can find the next problem. Shouldn't be much different. They should kind of go in a progression that is maybe, if anything, requires one step to get from one to the next. Let's do that one there. Something with fractions sounds good. So let me tell you that, before I know I'm going to let you do it, but what letters would you use in this problem? Just hopefully I've inspired you a little bit. What letters would you use for your unknown quantities? S and G. Does that make sense to you to use S and G? Salsa and guacamole? All right. Anybody think they got it? That one says that S equals 1/6. Right, so I'm looking, well, actually, they're asking for the number of calories, aren't they? So I'm using S and G for the number of calories for salsa and guacamole. So it does say 1/6. S salsa. Unfortunately, it spanned more than one thing, but there. That reminds me, first time you ever saw a G like that, did you get weirded out? First time I encountered that thing, I didn't know what that, nobody writes a G like that, do you? Did you guys see what I had issues with it when I was a kid. Anyways, so you got S and G. S equals 1/6 G. But there's another equation around here somewhere. Where is it?
S plus B equals 175.
That's right. This right here says that S plus G equals 175. So I've got two equations. That's important. You need two equations because you have two unknown quantities. One equation will not be enough. Two. Now, what am I going to do to solve this equation then, do you think?
60 plus B.
Right, I'm going to take this guy right here. I'm going to substitute it into that spot. So what's my new equation going to look like? All I'm doing is replacing the S. And there's a multitude of ways of doing this type of problem like this. So how would you like to go about solving it? The problem with it, though, is one is 1/6 and the other one is 1. So you need to give me an expression for 1 and 1/6. Or there's another way around all this. Do you remember another way to avoid fractions altogether? What would you do? Multiply everything by 6. Entire equation. You can completely do away because you'll take the 6 and multiply everything. What's this called again? Distributor property, right? So I'll take 6 times 1/6 G. And you might think it easier if you put it over 1. Then I'll have plus 6G. And I'll have 6 times 175. $1,050 or 1,050. Am I correct? What would you do now? Divide both sides by 7. $150. So I've got my G, and now the S is 1/6 G. So S is 1/6 times 150. But it's probably easier to put it over 1 like that. And then you can see if you look, the 6 we'll go into the 150 25 times. So we have our answers. The guacamole was 150 calories. Does anybody know why the guacamole is so heavy?
So plenty of good thoughts.
It has great calories, as they say. But does anybody know why so much? It's not sugar.
Is there the fats in there?
You get that. It's got a lot of
Yeah,
fat.
a lot of fat.
It's good for cholesterol and things like that, but it's got a lot of fat. That's why salsa has practically, well, it has no fat as far as I know. It's just mashed up vegetables and so. All right, let's go ahead and take a break there. Come back, I don't know, get some coffee or something because we got all word problems when you come back. It's going to require your brain to be functioning.
Coming to a math class, it's gotta be doing. 29.
I think that up to 175. Oh, I'm going to look at your. Yeah, the key is solve your equation one letter. You don't want two letters in your equation. You can't do it. Later in the semester, we'll come up with ways of doing it, but they won't be much different than this. This is just um, doing word problems in a certain specific way. And later on, we'll show you another way to do the same problems. Okay, well, let's go on to the next here in this is really important. So I'm going to take some time on this one. This is a very important topic. Do I want to put it here yet? I don't want to actually. I'm going to draw some pictures, very simple pictures. Something like this. Stop after I draw the picture. Can you understand the nature of my picture? How long is that thing? 16 whatever. 16 units, I guess you could call it, right? Now, what if I go and slice off 5 from how much is in the empty spot? How did you get it? 16 minus 5, right? That was equal to 11. It's not as straight as I want. Say this one is 38. Slice off 19. What's left of the empty space? How did you get that 19? 38. It's okay. Or it would be shorter. Can you tell me what the blank spot left over is on this one?
2.
How did you get that 2?
6 minus 8.
You didn't do 6 minus 8.
8 minus 6.
You guys get the idea? Coming up with an amount that's left over. But take away a certain amount, you can tell me how much is left over. Now watch all of a sudden it become part of the next step. Okay, now watch what I'm going to take away. It's left with the blank space. 10 minus x. If I took away 6, I'm left with 8 minus 6. If I take away 19, I'm left with 38 minus 19. Take away x, I'm left with 10 minus x. How much is left in the blank spot? Got it. You guys get the idea? This is the way of using, notice that I'm using one letter, x. But if you know the value of x, then you would know both of these, wouldn't you? That one letter is capable of answering for 2 questions. So being able to use this idea of where you come up with an expression for what's left over is extremely important throughout the entire course. Let me do the next example to show you. I think I had it still copied. A 40-foot board is cut into 2 pieces. 40-inch board. I say 40 feet. So immediately, a 40-inch board is cut into 2 pieces. Can you tell me how much one piece is called X because I'll be asked to find the length of both pieces? What's going to automatically be the length of the other piece? Don't answer the question. I'm still setting up. What should I put in the blank area of that thing that I drew? A minus X. So one piece is X, the other piece is 40 minus X. Understand? Now I'm ready to answer to deal with the problem. So half the setup is finished. One piece is 8 inches shorter than the other. So how do you want to work that? One piece is which one? So one piece, which one? X is 8 inches shorter than the other. So there's the other, and then how do I make it 8 inches less? Minus 8. The other piece. One piece, the other piece, minus 8. Notice that this equation only has one letter, doesn't it? Now, what would you do to simplify, or what would you do to solve this? I wouldn't do that yet. Combine these. Now, what would you do? Add X to both sides? So 2X is equal to 32. I'm ready to finish it off. Divide by 2. So when I cut up the board into 2 pieces, one of them has a 16. Can you tell me what the other one has? Right, you got 24 out of the end. How did you get that 12?
It's 8 less than
Up there.
So 16.
That 16, 40 minus 16 is 24, isn't it? Or, didn't we say if we took 1 and subtracted 8 from it, we would get the other? But either way you slice it, you've got both answers. So one piece, you've got 16 inches for one piece, and the other piece was 24 inches. Isn't it funny though, that I can do these problems all day long and you can give me the answers, but as soon as we did this, all of a sudden it became boring. Isn't that odd? The moment we had it in the word problem, all of a sudden it became different. That is a question between you and your head to try to figure out why. All right, moving on. Let's grab another one. I'm gonna grab one just like it. This will give you a chance, if you didn't get that one, to redeem yourself. Look, we even have rows. That's perfect. You can literally picture it in your mind. Whoa, oh, I see. It lets me stretch farther. I got it. Hopefully you can read it while I'm playing around. Oh, you devil. Anybody think they got it? Make sure when you list two answers, one of them is 1/4 of the other one. You got it? Did you label the two pieces like that? One is x and one is 20 minus x. It's another equation here. Is there another one that you think comes from the words? The second one.
4x.
Equals what?
Well,
It says one piece. What is, tell me which piece do you want? The x or the 20 minus x?
21
One piece. Okay, so one piece will be 1/4 of the other piece. You could have actually rewritten it as x equals 1/4 20 minus x.
This would have been acceptable as well.
But if you do it this way, make sure you have parentheses around the 20 minus x. Well, now that you got it in that form, how would you solve, what would you do next? Multiply everything by 4?
Good idea.
Well, multiply everything by 4, so we look like this then. I get a 4 times 20 minus x equals x. So that's what happens after I multiply by 4. Now what?
Distribute the fourth row.
Minus 4x is 4x. I'm open. Okay, now what? That's 4x. Right, so we get 80. It's 5x. 5 by 5. So you get 16 is equal to x. That means when I cut this up, this guy here was 16. What's this one going to equal? So our two lengths are 16 feet. 4 feet. Ready to try another rope like one? I think if there's one in there, if not, I'll grab an odd one. I will be almost identical to the one you just did. Here we got 3. Oh my Lord, 3 pieces. Too bad I'm not going to go that far. So I have 3 pieces. All right, so we've got 2 pieces there. 23. So Trisha's working on 2 pieces. All right, let's try Trisha. So now that you've had 2 of the same kind, hopefully everybody will get this one. And I will feel comfortable by moving on. Anybody think they got it? You guys think you have it? Let's take a look at our equations. First of all, Tricia has a 28.5-inch piece of wire, so we immediately know. Put that in 2 pieces. Got one of them X, the other one is 28 5 minus X. So notice in these problems, I didn't have to introduce a new letter for any of these things. I already have 2 quantities represented by the same letter. Now we have a second equation. Where is that second equation? So, which one of these do you want to be the necklace? Either one of them could be the necklace. One is the bracelet, one is the necklace. Pick one. X for necklace, all right? The necklace will be twice as long as the bracelet. Yeah, I even said it verbally to show you how it works out. Did you get that equation in? So then your answer gave in reverse then, was it, or no? All right, so if you reverse it, it doesn't matter. You can put 28.5 minus X on the left, put X over here. You'll still get the right answers. All right, so let's see what happens when I multiply the 2 through. I get 57 minus 2X. That equals X. What would we do next? Let's add 2X to both sides. So it looks to me like I have 3X equals 57. Great, math, what next? 3. So we get X is equal to 19. All right, that doesn't answer the question. The question says I need 2 answers. Find the length of each piece. What did I find the length of? Okay, so the necklace is 19 inches. How do I get the other piece then? You can do that, is that right? Is it 2 S's? For necklace. There's a C. Okay. All right, so you've got that one, the necklace is 19 inches. How do I get the other one then? 28.5 minus that. So if I take 28.5 minus 19, that'll be 9.5. And so the bracelet is 9.5 inches. Even if you get these numbers and you forget which goes to which, you should be able to use ordinary logic and go, well, the necklace is going to be longer, isn't it? That makes sense to you? So the answer should make reasonable sense when you're done with it. We're good here. So we've done, it's the same style of problem. In fact, the entire class, I've only done one style of word problem. The whole class has been one problem. Let's see if they have any others in this. Ah, yes, these things. So a different style of problem looks like this. First of all, one of the things we've been studying to try to help students with classes like this is reading comprehension and things like that and determine what it is that students know. When you look at a thing like this, do you understand all the words, first of all? What does consecutive mean? No, in a row. So I want the sum of two integers in a row. What would that look like? Okay, if we called one of them X, fine. There's two of them though. What would you call the next one? No. And you could do that, and you probably could get an answer that way, but that's not what I'm looking for. I want to use the same letter X for the other quantity. So one of them's called X. What is the next one called? Nope. All right, let's try it. Let's back up a little bit. I'm going to give you an integer, and then I want you to give me the next consecutive integer. Okay? So I say 5. What's the next consecutive integer? All right, how about negative 12? No, you're going the wrong way. Negative 11. How about 0? 1. Each time you add 1, right? So if one of them is called X, what do you do to get the other one? Add 1 to it. So what would they look like? All I'm asking you for is give me a version of what this looks like before I write down any equations. Nope. Well, that'll actually, yes. If two consecutive integers will look like this, if they're in a row, consecutive means that if I call one of them X, and I will, because boy, that's what you do when you're trying to solve these. The next one after it is X plus 1, isn't it? Aren't those two integers in a row? Not one, and then add 1 to get to the next one. That's basic, right? So those are my two integers. So it says the sum of those two things is 171. So how do I set up an equation? This equation I will set up. The sum of be this plus this. You see that? There's one integer. That's the next one. Sum of them was 171. Now, simplify. And then solve it and figure out what X is. If I subtract 1, I get 2X equals 170. So when I divide by 2, I get X equals 85. So can you tell me the answer to this problem? 85 plus 86 equals 171, but that's not what they asked me. Sorry, the answers are 85, add 1, and 86. And if you do those two, they do add up to 171. So if they're two in a row, you got X and then you have X plus 1. But if I had 3 in a row, first one started at X, what would the next one be? X plus 1. That would be the next one after that. X plus 2. What if they were just even ones and I started at X? What would the next even one be? X is an even number. I don't know if I said that. X is an even number. Tell me what the next even one looks like. X plus 2. Don't you jump by 2s? Or if X was odd, the next odd one is how much over? X, no. It's odd, it's 2 over. So like 5, how much do you add? What's the next odd one after 5? 7. 2. That's because the odds and the evens alternate, don't they? All right, so those will be useful for the problems that we're going to do. For some of the next ones. Right here, look at this next one, number 20, number 30. That's exactly what I was talking about. When you have it, let me know. I'll come by and show you. Think you got it? Smaller one is 12 more than one. So what do these two odd integers look like? If you were to give them names off the bat, what would you call them? What would you give these two consecutive odd integers? I would call them x and x plus 2. Because if they're odd, next odd one is 2 later, isn't it? Well, if I have an odd number, how much do you go to get the next odd one after? Add 2 to get 3, add 2 to get 5, add 2 to get 7, it goes on forever. So, well, this also, notice that this also tells you a little more than that. It tells you that x is the smaller quantity, isn't it? But you'll need that for the next thing. The smaller one is 12 more than 1/3 larger. So the smaller one, which of those two is the smaller one? X is 12 more than 1/3 of the other one. So that way you're able to write the equation directly underneath of that sentence. To solve this equation, then what would you do next? You could do that. I probably would multiply by 3. You can distribute the 1/3, then you'll have more fractions to deal with. But I would prefer to multiply the whole thing by 3. so that when I multiply it, I'm gonna do my distributive underneath this time. It's gonna wipe that 1/3 out. So I'll get 3x equals 36 plus x is 2. You see I took away the 1/3 by multiplying like that? Now what would you do? I wouldn't yet. What's my first thing I would do? Find your like terms, so simplify before you do any solving. 36 and the 2 adds up to be 38. Subtract x. So I get 2x equals 38. Now what? By 2, we're almost done after that, practically done. And x is equal to 19, there's one of them. And then what's the next one? There's the first odd number. What's the next odd number? Don't think. What do my answers look like? One, I've already given one. One odd number is 19. What's the next odd number? Say 21. Isn't that the next odd number after 19? One of them is 19, the other one is 21. So my answer is 19 and 21. That is 2 consecutive odd integers, isn't it? 2 consecutive odd. They have some of them, I think they do 3 consecutive odd or 3 consecutive even. And it's no different, it's just a little more complicated is all. Now what do I have? What's that? Yeah, look at my, did I have it? Where's my equation? Hit there? 12 more than 1/3. No, this is just an equation. This is, no, you already know, if they said 2 consecutive even integers, that the other one is 2 more than the smaller one. So they can't violate that principle in the next sentence. So those are the consecutive integers one. And then this is just a mixed, do you want to do a mixture or should we do one? Let's do the even integers because the rest of the problems are going to be a collection of just like the ones that I've done. So also we have a short amount of time, so I can't let you just go all willy-nilly on it. I have to kind of keep things going. So, but first of all here, I think this is a useful problem too. I have delivered pizza. Anybody here deliver pizza or delivered anything? You rely on the fact that those one side of the street are the odd numbers and the other side of the street are the even numbers, don't you? You have to. Well, that's what this is about here. The addresses on the west side of Hampton Street are consecutive even integers. And then 2 consecutive house numbers add up to 7, 4, 4, 6. Start up, first of all, tell me what 2 consecutive even numbers are going to look like. Start with that. 2 consecutive house numbers. Can you tell me what they look like? Just give me some name for them. One of them's called X. What's the next? X. And X plus 2. Those are my names of my house number. Okay, now, you know when you get done, if you get a decimal or if you get an even number, an odd number, you know you're wrong. The answer that's going to be right is an even. Now give me an equation that I can use. No, X is not going to be close. Just like saying the smaller one equals the larger one. Does that thing mean anything to you? The sum of those two house numbers is 7446. So in my mind, X is out one house number, X plus 2 is the house number after it. That's all I'm thinking about. Forget about the fact that X is equal to 11. I'm looking at the sum of two house numbers. The first house number plus the second house number added up to 7446. Now what would you do?
Simplify.
Right, so what'd you get on the left side?
2x plus 2.
2x plus 2 equals 7446. Now what? Subtract 2. So we end up with 7444 equals 2x. Divide by 2. I think it's 3722. Is that right? So what is my answer then? There's two answers. They're asking you for two of them.
So we got 3722 and 3724.
That's right. 3722. 3724. Consecutive house numbers. Are they even? Are they consecutive? There, that's what's important. You gotta make sure. And you can even take, if you want, add those two together and make sure that they add up to the 7446. And I think I can tell that they do. 37 plus 37 is 74, right? 24 plus 22 is 46. Any questions? That went faster than I thought. I don't think I can do another question in the time left, so I'm going to stop it there. Unless you have a question. All right, we will adjourn. Let me go ahead and stop recording.